Hello everyone, I'm Huiping Zhang from Institute of Geology, China Earthquake Administration. As part of this low temperature thermochronology class, I'm glad to have this chance to present this introductory section. I will briefly show you some ideas of the tectonochronology. As the title shows, tectonochronology has two obvious aspects. One is tectonics, meaning this is partially related to tectonics and structural geology. It mainly focuses on the spatial dimension of the Earth to answer what is the deformation. The second part, chronology, means time, to answer the question, when did the deformation occur? To understand a whole evolution history of the Earth in 4 dimensions, we need to integrate them both. Our Earth, in a long-term scale, evolved through a system called plate tectonics. For example, the Tibetan Plateau has developed since the last 50-60 million years. The Indian plate was separated from Gondwana during the Cretaceous and plied the Eurasia plate later on. Understanding the development and the formation of this is crucial for continental dynamics. This is general geological view of the whole plateau. As we can see, it comprises several terrains. From north to south, there are Qilian, Songpangan, Qiangtang, Lhasa terrains. In order to understand the geological evolution, we need two aspects of studies. First, what is the deformation? We need to know the relationships between different structures. We use basic geological mapping to map the outcrops. Try to collect all kinds of samples to understand the structural geometry, cross-cut relation, and recent activities. The bottom right figure shows you a fault rupture during the 2001 Kunlun earthquake. Most of the brittle deformation was accomplished through thousands of millions of earthquakes during the geological history. Well, we have the tectonic structures at hand. We may ask further, when did this deformation occur? Therefore, we need an age to constrain the time of the deformation. For most of the course, you will learn about the low temperature thermochronology. All ages are related to the temperature structure of the shallow crust. Simply saying, our sampled minerals should be cooled below a temperature to start our timing clock. Different minerals have different temperature zones to cool. We call it partial retention zone or partial annealing zone. You will get familiar with this during our coming class. Okay, once we have the geological mapping data and the age constraints, we can tell you a story, a fantastic story of the Earth evolution. Luckily, you may have a very good publication if your story is interesting. This slide shows an overview paper after the 2008 Wenchuan earthquake. Based upon a lot of field observations and dating results, the paper summarized the geological evolution of the Tibetan Plateau, especially the eastern and southeastern Tibet. During the class, we will bring you more theories and practices of the chronology aspects. Then you can use them as a powerful tool to explore the tectonics and evolution of the Earth system. For a short summary, we will also present you some of the applications. For example, the structural geology, understanding the exhumation phases of mountains, and try to date the fault activities. Second, we can also study the sedimentology, try to trace the sediment and link the source to sink system. Third, we can also explore the oil and gas reservoirs. Since most of the fossil resources are thermally related, we can use low temperature thermochronology to quantifying the oil and gas reservoirs. Fourth, basin thermal evolution. We can study the burial processes in sedimentary basins. Because the sedimentary basins can accumulate lots of sediments, this overthickening can also change the thermal gradient, and we can try to date this change by low temperature thermochronology. And finally, geomorphology study. We can use low temperature thermochronology to decode the information for landscape evolution and tectonic geomorphology, understanding the evolution of our dynamic Earth. Finally, I left my email here and welcome for your questions and comments. I wish you have a good time during the class.